Gentlemen, you're all very welcome here to Engineers Ireland Clyde Road. My name is John Kane. I'm the chairman of the Energy and Environment Division, and I think my job today is to be that like a good soccer or rugby referee, in that I'll stay out of the way and let the talent shine through. So without further ado, I'll just ask you to take notice of the fire exits at the back and to the side, and if you could all switch your phones to silent, that'd be fantastic also. We have a great lineup of speakers today. We have Brennan from the SEAI, we've Joe Mooney from ESB ECars, and James McCarthy from Nissan Ireland, and the guys are all very welcome here today as well. So we'll have the quick run through, a run through of the presentations with the guys. If we can hold off our questions towards the end, that'd be appreciated, and then we can have a general Q&A towards the end. And a final note to say that this event is being co-hosted by the Energy Institute as well, so we're very happy to have the guys on board. So without further ado, guys, I'd like to welcome Brennan from the SEAI.
Thanks very much, guys. I'm delighted to be here, and I have a bit of a sore throat, so apologies there in advance. So this is the layout for the discussion. We're just going to walk us in nice and gently. We're going to talk about diesel issue and rising pollution, talk a little bit about climate versus environment. What's the difference? What do we mean by the difference between those two? Then we're going to get nerdy. We're going to talk about electric vehicle technology, batteries and motors. So the motor side of it is sort of the unsung hero, especially if you're mechanical engineers, maybe a bit of a mystery in some cases. I myself am mechanical, so I've kind of learned to become more of an electrical person, let's say. And then we're going to talk about the EV market, what's happening in Ireland, and what's going to happen in the future. So here we go. On the far right there, my left there, you'll see a picture of smog in Paris there. So smog is produced from NOx leading to ozone. So that gives it a bluey tinge, and then particulates give it a browny tinge. So if you look across the city, you'll see this kind of a browny blue tinge. That's smog. Europe, so let's say when we talk about climate policy, we talk about CO2, we talk about fuel efficiency. And when we talk about environment, we generally talk about toxic emissions, particulates, NOx. So that's the health aspect of it there, let's say air quality. So when Europe decided to reduce the CO2 content, it focused perhaps too heavily on the climate change side of things. So the objective function was to reduce the CO2. So everybody knows what the CO2 footprint for their car, they know what the CO2 label for their car is, but very few of them know what the toxic emissions are. So that policy led to the promotion of diesel. It also led to the promotion of biofuels, liquid biofuels. So you burn biofuels, okay, you get some reduction in CO2, but what about everything else that comes out? It's still as dirty as a diesel engine. It's still making the air as dirty as a diesel engine. If you put the two lenses together, climate change and environment, you wind up with an electric car. So you get no emissions in the city, an overall reduction in emissions. So that's something that's leading to the hope that electric vehicles can help us. So you can see on the right, on my left there as well, you can see doctors are starting to get involved in the argument. Doctors Against Diesel, a group formed in London. And you can see cities responding and say, well, we're not waiting for European legislation to do anything. We're going to start banning diesel cars, and some of the cities have signed up to that. So some of the countries have signed up for zero emission policies. So by promising or committing to a zero emission future beyond 2030, in the consumer's mind, without paying a penny for a subsidy, you're creating this psychology, I'm going to buy a car now. Well, actually in 10 years, if the guys are going to tax the hell out of me, maybe I should look for the cleanest thing I can get now and protect the value of my asset. So I think it's an important thing that we should commit to ourselves. So EVs, gas and hydrogen can all do the two things together. They can all contribute to climate change and reduce the environmental and improve the health quality aspect. So what are the immediate things that EU has started to do? So the first thing is there was a debate about how realistic the test cycles were. So on the top graph there, you can see, I forgot this laser right, where it is. Let me see. Top graph here. Any vehicle that was built before 2017 has been tested according to this, the new European drive cycle. So you can see there's a couple of urban cycles here and an extra urban cycle there. And you can see the average speed really doesn't get much beyond an average of about 60 kilometers an hour here. So when you bought your car, it was tested according to this rigorous cycle, and every vehicle was tested according to this. It was noticed that the actual emissions were deviating by about 30%. In particular, NOx was deviating by a factor of 4 or 5 in some cases. So the EU decided to change this and introduce this new, more real-world test cycle here. And in addition to doing that test cycle, when the vehicle has done that test cycle, they're going to take it around and actually stick a thing on the tailpipe and measure the real-world emissions. So some deviation is allowed, post 2021, a deviation of 50% will be tolerated, but before then, a higher deviation is allowed. So the two other policies they brought in, this Alternative Fuels Infrastructure Directive. So they've said that all governments have to have a mandatory amount of infrastructure in place to cater for natural gas, electric vehicles, and fuel cell vehicles, CNG and LNG vehicles. So Ireland is committed to that, and it's developed its first framework to explain the number and variety of these that they're going to facilitate. The second thing is they've said the Fuel Quality Directive has now been expanded. So basically what they're saying is anybody that's supplying fuel for transport has to reduce the greenhouse gas content in that fuel. They don't care how you do it. You can do it through a combination of natural gas, biofuels, EVs, or hydrogen. So they're the two things there that they'll be looking to actually get change happening in the next couple of years. So let's look specifically now at EVs and how they fit into this equation here. So we have kind of an illustration of the energy efficiency of these vehicles. So at the top we see the diesel vehicle here. Typical efficiencies in the region of 25%. So the actual useful energy you get out in terms of transporting the vehicle all around, about 25% of the diesel energy that was put into it. If we look at the electric vehicle, we see here that the power station and the combination, this represents really the combination of power stations, whether it be renewable energy, natural gas, coal, or whatever. The average efficiency of these is about 45%. So average efficiency of generation is something like that. About 10% is lost transmitting that electricity to the consumer, but the electric vehicle itself is hugely energy efficient. It's got regenerative braking. You'll see that the battery itself is hugely energy efficient as well when we get on to talking about that. So overall, you tot all that up, you get about 30%. So we can say that the electric vehicle, if we can make this cleaner and cleaner each year, the emissions from that are going to reduce each year. We can say that the diesel car, as it ages, the emissions from that are going to rise each year as it gets less and less energy efficient. So here we have, you buy this car, each year there's the potential to have fewer and fewer CO2 emissions associated with it. So that's excellent news. And an illustration here of hydrogen, just for completeness. You could see in Ireland, you have two ways. You either manufacture the hydrogen from gas or from coal, or you make it from electrolysis. Seeing as how we don't have huge reserves of gas or coal, if we made it from hydrolysis, this is the kind of efficiency you'd get. And then you've also got to compress that stuff up to about 700 bar to get it into the car here. The fuel cell is less efficient than the electric vehicle. So you can imagine the fuel cell car as a less efficient electric car. Still, it has benefits in terms of zero emissions here, zero harmful emissions anyway. So probably this is better suited, given the head start that electric vehicles have had. This here might be better suited for the heavier vehicles, where the cost of carrying heavy batteries gets outweighed by the cost of carrying a fuel cell plus hydrogen tanks. So we're not going to talk about this, we're going to talk about electric vehicles now. We're going to look at some of the technology, just the basics really. So this is a lithium ion fuel cell, okay? So we have our anode here on the side, the cathode over here. In discharging mode, what we have is a graphite crystal almost. So this is shown here to represent a crystal structure. The lithium ions are actually inside the crystal structure. So if you had something like a lead battery, the actual electrode, all the action is happening on the surface, okay? And the electrode gets dissolved in the process. This thing stays in place here. The ions, so what happens is you've got two chemistries here. You've got the lithium carbon chemistry here, and over on the other side then you've got something like permanganate. So they've got two different electrode potentials. The electrons want to move across to this side to complete the reaction. they can't move through the electrolyte. So they have to move outside the circuit to complete it over here. So once you turn the tap on here and make the connection, the electrons start to flow this way. The ions start to move across here, complete the reaction on this side, and that's discharge. So again, you have another metallic crystal on this side. So it's going inside the crystal structure itself, okay? And then when you want to charge it, you attach a voltage in the opposite direction across it here, and this drives, the positive current is driven this way. So the positive current is going that way, the electrons are going that way, and then in charging, you're going in the opposite direction, and they fill up again here. And this process happens to be very efficient. So it makes the lithium-ion batteries very efficient. So if we look here, in terms of the cell voltage, so the basic chemistry, each cell is able to create about 3.6 volts, as opposed to 2 for a lead acid. So voltage is energy per charge. So that means you almost, you're sending twice the energy for each electron that goes down the wire. So it makes it much more, it reduces the losses and all sorts of things within the battery itself. The I-squared losses can be lower and things like that. In terms of energy efficiency, if we look at the energy, the round trip efficiency, the energy you're going to get back out is about 93% compared to 75% for the lead acid. In terms of depth of discharge, of the volume of energy in that, how much of it can you access? You can access 85% of what's stored in the lithium-ion battery. In the lead battery, 30 to 50%. So you're carrying around this dead weight, energy you can't access. 50% of that thing you can't get your hands on. And then, as we said, with the electrodes being part of the chemical reaction in the lead acid battery and the processes in it, we see the number of cycles, the number of charge-discharge cycles between 500 and 1,000 for a lead battery, between 2,000 and 5,000 for a lithium-ion battery. And here's the other thing. Lead batteries don't like to be partially charged. You've got to, once you start the process, you've got to finish it right to the end. This is not the case with a lithium battery. You can partially discharge, partially recharge, so it's far more convenient for use. And they charge a lot faster as well than the lead batteries. So it's got huge advantages, but this is the real kicker here. The energy density for the lithium-ion batteries is in the region of 100 to 210 watt-hours per kilogram, as opposed to 30. So what that means to the consumer is, now you can have a car that can actually carry a realistic size car and do the kind of journeys and trips that somebody needs, rather than a milk float. So this is really what's transformed it here, is the energy density available from this lithium-ion and all of the work. And here's two examples. You can see the Nissan guys here have gone and built from scratch their own lithium-ion cell. There's the electrode terminals there on the tips, and there's the configuration. So they've got about 400 of these things wrapped inside an EV. And then for Tesla, what they did was, these are Panasonic batteries, exactly the same as in your laptop. So they're the same as this, they're just rolled up like a cigarette, really. So they're little cylinders of this, if you like. About 7,000 of these packed into a Tesla car. So I don't think they own the intellectual property for that battery. So it's a big question underneath the basis for the business model for Tesla. Panasonic are doing very well out of it. So we're going to just talk about electric motors for a little while. So our DC motor here on the left, okay. We might have played with scale electrics as children. You know, the little trigger like that. So what you were doing was controlling the voltage on the motor. It's mechanically commutated. So the current is changing direction within inside it, and that's creating a rotating magnetic field, and it drives the shaft around. So the problem with these DC motors is you need brushes, okay? So carbon brushes that burn away, things like that. Speed control can be inefficient. Imagine your little scale electric car, you pull the trigger. Well, the top part of it is being burnt, so you're setting the voltage using dividers, if you like. So that's the voltage you're going to give to the battery, to the motor. The other half of the voltage that you've divided is sent through a resistor, and it's wasted as heat. So it's very inefficient control, that kind of a control. But the beauty of it is you get massive torque at startup. That's lovely. We want that for a car. You've got to accelerate a big mass, get it down the road. So we don't want the brushes. What else can we look at? You can look at an AC motor here. So what we have is AC field, which creates a rotating magnetic field using the frequency of the electricity system. And that's spinning around like that at 50 hertz, let's say, okay? So it induces magnetism within the rotor, so it doesn't need any brushes. So that's nice, we like that. Problem is, it's got one preferential speed. It's stuck at the frequency of the grid. So that's not great. What it means is if you're starting up your washing machine, it's got low torque at the start, and it eventually catches up and meets the speed of the grid. So that's not great either. So we want that. So how can we actually square the circle here? So the answer is, if you could produce a varying frequency, you could have the advantages of this and the high torque of that. And that's what we get with these variable speed drives. And the magic that makes it happen is this high-powered transistor here, okay? So it converts DC to AC. So all it's doing is basically, you're putting DC in, and it's switching the terminals, and it's making the electricity go back and forward inside the motor. And you can control the speed at which that frequency switches by controlling the speed of this transistor operating here. So these power electronics have been developing over the last couple of years, and these are the same things that have enabled variable speed synchronous generators to be used in wind turbines as well. So you can see a cutaway here of the Nissan stack. So down here is the motor. Inside there is the rotor. You can see it's very, very close to the edges of the stator. And in this case, they're using permanent magnets. They're using permanent magnets, neodymium from China, and they actually make the motor nice and small and compact, which is exactly what you want for a car. You want a nice small motor. Here is our inverter. So this is the piece of magic here that's using these fellas here. The transistors are all underneath this board here. That's all stuffed away in here. And up here is the actual basic power conversion unit, taking the DC or the AC and converting that and spreading it to the batteries. So that takes the power. So they're the main components over there, but a lot of work has gone on to shrinking these motors and making them nice and small. So just to give you a kind of practical example of what it looks like, this is the motor from the Tesla. This is actually, so they have all that variable speed control that you've seen there. Inside here is the rotor shaft, again, very, very close. This is an induction motor, actually. So this one doesn't use rare earth magnets. So they've chosen a different path. But interestingly, the new Tesla car will use rare earth magnets. So they're actually dropping their own idea, if you like. So that's what it looks like. 270 kilowatts is the power output. I tried to find a weight figure. I think it's about 32 kilograms I've seen. And just to give you a comparison, this is a 2.5 litre petrol engine. 270 kilowatts is the stated output, about 183 kilograms. Look at the work and effort gone into building that engine there. Here are the Tesla motors installed. So you can see it's a very neat power chassis, if you like. This is the actual battery pack stuck in here underneath. It has two of these motors stuck in here. You can get an idea of the scale with respect to the wheel. So it's enormous power stuck in there. It's huge, very neat and tidy. So overall, what we're just saying is, you can imagine, you've seen what the cells look like. They shouldn't be that difficult to mass manufacture those cells, right? These guys here, there's a lot less work in building these things compared to this. These should be cheaper than these as well. So you can see, once the volume, it's just simply a question of volume. Once the volume of these vehicles get up to a sufficient level, they're going to be far cheaper than these combustion engine vehicles in the future. So there we go. So we're going back now just to see what's going on in terms of Ireland's market, what's been happening. And so this is from SEAI's data. We've taken the average price of every Leaf that's been sold. This is the price of the Leaf after the subsidies have been given to it. So we give about 10,000 in subsidies in total. So you can add 10,000 onto that to get the unsubsidized price, if you like, of the vehicle. So we see about 31,000 starting off in 2011, dropping rapidly. And then we're looking here at what's going to happen next. The other curve here, so this is the price of the cars. The far side here is the actual NEDC driving range, the technical driving range of the cars. We started off at about 175 kilometers. The first Leaf came in. They started manufacturing it in Sunderland. They cut a bit of weight out of the car. The same battery pack, they managed to get 200 kilometers out of it. And then the first increase in the battery pack size gave you a 250 kilometer car. And now the new one, which is coming out in January, February of next year, expected range about 380, I believe.
Yeah, 278.
Yeah, so I was looking for the kink. Yeah, there. It's around here. So 378 is the range. Not sure what the price is going to be yet. James, I hope you're going to be nice to us.
You can reduce that bar anyway, I can tell you.
Woo!
Yeah.
Thanks, James. That's great. So the man here is going to decide what this car is going to cost in the country. And then this car here coming out in 2018 is going to have what's called CHAdeMO fast charging. Okay. The one they're bringing out the year after, I don't know, again, if we're going to have it in Ireland, hopefully we will, is going to be CCS. So CCS is the European fast charge format. So we have a legacy of CHAdeMO. We have to accommodate those vehicles. So they're hedging their bets here. The second car coming out is going to have an even bigger battery pack, and it might even be 475, 480. So we don't know yet. So that's all to look forward to. So there you go. There's real proof. Prices coming down per range, if you like. Okay. So now, what's been actually happening in terms of sales in Ireland? So when we say EV, we mean battery electric vehicle, but we also mean plug-in hybrid electric vehicles. Okay. So we've been given grants for both types. So the BEVs are down at the bottom in the blue here. The purple are the PHEVs. So we've really seen growth in the PHEVs since BMW started producing their 3 Series and 5 Series in PHEV format. Up until then, it's been all the Nissan Leaf really driving the whole thing ahead. And now we're starting to see this phenomena here. EV imports, okay? So they're starting to rise. These are the number of registrations per annum in the country. About 3,600, if you tot all this up, 3,600 cars cumulatively on the roads. The split is 80-20. 80% of them are battery electric vehicles. And we want to maintain that because the environmental benefit from PHEVs is uncertain. It's down to behavior. Is the guy diligent enough to plug it in every night? The BEV driver has to plug it in every night. So again, it's a thing. So we're pleased with this. Now, and of course, it's the euro sterling exchange rate is doing the damage here. It's not just for EVs, but it's also harming the car sales in general in the country. So it's a consequence of Brexit uncertainty. So there we have it. What are the manufacturers telling us about the future? So these are all statements from manufacturers. On this side here, we have the NEDC technical driving range. You can knock between 20 and 30% off to get the real world driving range. So here we go. The green are what's currently available on the market at the moment, and these purple dots are statements that manufacturers have made about products they're going to be making and selling into the market, and the dates they're going to introduce them. So what we see here is the Renault Zoe, the 40 kilowatt hour Zoe that came in there, 400 kilometers range. We have a cluster of cars here, the Ioniq, the Leaf 30 kilowatt, and the BMW i3, all in and around the 300, and the BMW is in there. Sorry, the Volkswagen Golf is in there as well. We have statements here, so we have the new Nissan Leaf coming in here next year. We have the GM Bolt, Opel Bolt, hopefully we'll get it. It will be 60 kilowatt hour, and the Audi Q-tron coming in next year as well, an SUV coming in here. And then we look forward to what Volkswagen are saying. So they're saying they're going to have something like 100 kilowatt hour plus battery up here. It'll be 600 kilometer range. By 2020, that will be their kind of core platform for electric vehicle offerings that they're going to make. So we're seeing a general trend. It's not unreasonable to assume after 2020 that the batteries are going to be in the 100 kilowatt hour range size with a driving range of 600 kilometers. So that's what we're looking at going into the future. How fast will the cars be charged? This is the next statement again from manufacturers. These should be green here. So we have power here. How much power can you get into that battery? And then we have data along the bottom. So down the bottom here, we have about, I think, 5 kilowatts here. So if you charge your car at home, you can charge it at a rate of about 5 kilowatts, let's say. Your house is able to take about 14 kilowatts, I think, based on a 64 amp fuse. So that's what you can do at home there, okay? The street chargers work at about 22 kilowatts down here. And then our current fast chargers are 50 kilowatts. Now, the Nissan Leaf can take, most of the cars out there can work at this 50 kilowatts here. We know that the Ioniq is designed, the one that's out there on the roads, is capable of 100 kilowatts, I believe. They're using polymer batteries. But anyway, this is my own test here. I took an Ioniq and I brought it into the petrol station, nearly empty. In 30 minutes, I got 170 kilometers range on it. I checked the computer to see did it actually come out. It all totted up fairly accurately, actually. I was really impressed. So if we bump up, so that the proposal now is to increase the CCS and the CHAdeMO fast charging standard from 50 to 150. And already we see 2 manufacturers there, Volkswagen and Audi, committing to vehicles that will charge at that rate. If we took that there pro rata, very roughly, you're looking at a 10-minute charge for that same range, 10 minutes to get 170 kilometers. But a lot of the luxury manufacturers aren't happy to stop there. The US Department of Energy isn't happy to stop there either. They're looking at 350 kilowatt power range. And our little example here would mean about 4 minutes to get 170 kilometers. Again, 2 manufacturers already gearing up to produce these chargers. So I'm not going to say any more. You'll hear a bit more from Joe now later on. And really that's it. So you got a smattering of everything there. You see what's going on, what's happening in Ireland, and where the future is taking us. So thanks very much.
Good morning, and thank you for having me. My name is Joe Mooney from ECars, and I'm going to talk to you a little on EV charging in Ireland and the changes in the technology. So, back in 2010, ESB was tasked with the rollout of the charging infrastructure across Ireland to support the introduction and demand for EVs nationally. A target of providing a charge point in every community with a population over 1,500 or greater was set back then. Today, across Ireland, there are 1,100 standard AC outlets capable of providing up to 22 kilowatts. In addition to this, we have 90 fast chargers stations with a power output of 50 kilowatts DC. Now, just to quickly touch on the various connections used for those who aren't familiar. The standard for AC charging across Europe has now been established as the Type 2 from Menicase. This was developed with 3-phase in mind. Following on from that, we have the CHAdeMO connector, which was developed by the Japanese manufacturers for fast charging using DC. This was the first DC connector for EVs and was used by the Nissan Leaf, the best-selling EV with 300,000 cars around the world today. You'll see a few variations of the CHAdeMO connector out there, as shown here. The early CHAdeMO connector from Miyazaki, here on the left, was generally found to be difficult to use, but other manufacturers developed much improved versions, and today you're more likely to come across these. Tesla, one of the main disruptors in the automotive world with regard to EVs, has developed a proprietary connector which they use themselves. So they have developed an adapter so that they can take advantage of the CHAdeMO charge point. This opens up the vast number of 50 kilowatt charge points to Tesla drivers. Then moving on finally to CCS, or sometimes referred to as combo. And as the name suggests, the connector is a combination incorporating both AC and DC. There are 2 variants, one for the European market, as Type 2 is the European AC standard, and Type 1 for the American market. This alternative to CHAdeMO is driven mainly by the German and American automakers. The first public station appeared in June 2013 in Wolfsburg, installed by the Volkswagen Group. In Ireland, ESB introduced CCS back in 2015. So in Ireland, when we started introducing CCS to our network, we took the decision of applying multi-standard stations which could support both CCS and CHAdeMO, as well as fast AC. The reasons behind this is because we wanted to continue to support all EVs, and this has been the trend across Europe. Now, just to move on to what's coming down the line, and in terms of the future for EVs. Battery energy density has been increasing, while at the same time the cost has significantly dropped since 2009. Putting that into context, in 2010 the Nissan Leaf was launched, and at that time the cost of a kilowatt hour was just under $1,000. Today that's under $150. This can be seen reflected also in the battery capacity changes in EVs currently in the market, with kilowatt hours increasing within the same physical body of these cars. Now, with bigger batteries, charging times at the current power levels will grow. So there's been a trend moving towards higher power charging. And currently Tesla's superchargers provides power levels of 100 to 130 kilowatts. With the CHAdeMO standard is moving to increase and will be capable of providing 100 to 150 kilowatts, with CCS also looking at going to 350 and even 400. At these higher levels, charging times closes in on the time taken fueling at diesel or petrol, fueling a diesel or petrol car. One of the biggest challenges for the manufacturers in getting to this was the cable that goes between the station and the EV itself, which would not only deliver the high power, not only was required to deliver the high power levels, but also had to be light, flexible, and sufficiently cool to handle for the user. Thus, this drove the need for higher voltages as well as high currents and now liquid cooling. The other problem being faced as EV numbers grow is the number of points available at a site. Most of them today would only have 1 or 2 fast points, leaving little or no room for redundancy and increasing the likelihood of long waits. So, along with the move to higher power, these next generation chargers are moving towards multi-points and dynamic power management. Due to this and other reasons, the power components are being separated from that of the customer terminal. And finally on this slide, plug and go. This is something Tesla customers have already experienced, eliminating the need to present RFID cards, etc. Instead, the station will have the ability to recognize the car via communications protocols. This is sometimes being applied to CCS, and this is also being applied to CCS and CHAdeMO, making a simpler user experience. Now, infrastructure for larger vehicles, there has been a number of projects like that of the E-Highway by Siemens, run in California and Sweden, using overhead contact lines and hybrid electric trucks with pantographs, connecting to power them while on the move at speeds up to 90 kilometers per hour. In this area also of electric buses and BRTs being developed, with stationary pantographs charging systems operating at levels of 150 kilowatts to 600 kilowatts, providing for today's demands for clean air in our cities. And most recently, Tesla unveiled the Tesla Semi, along with their plan to provide mega chargers worldwide. These are expected to be in the order of 800 to 1600 kilowatts per point. And finally, just to touch on wireless charging of EVs. Wireless charging has been around for a while. We all know the humble electric toothbrush, and we're also starting to see it becoming available on new mobile phones. This is an area where automakers have begun to offer vehicles equipped with wireless charging. While it is unlikely to be coming to public infrastructure in the short term, it will begin to appear in people's homes with the convenience it provides. What's the future for wireless? Well, in May this year, Renault and Qualcomm demonstrated dynamic wireless charging along a 100-meter track, charging up to 20 kilowatts while traveling at 100 kilometers per hour. While this may be while it may be a while before this appears on our roadways, it shows the possibilities of what can be done and what could allow larger, heavier vehicles needing smaller batteries. And just to finish then, I hope this has given you a flavour of what's happening in the EV infrastructure technology, and gives you an insight in the changes happening and an idea of what we're going to be seeing soon. Thank you.
Thank you very much. My name is James McCarthy from Nissan Ireland. It's a pleasure to speak to Engineers Ireland. I work in the motor industry, so normally I'm listening to engineers, so it's a great opportunity to return the compliment, as it were, get my revenge. So, sorry, I was just going to start this by a little Bloomberg video piece showing their vision of the future of electromobility and its implications on society. And then I was possibly going to pick up on some of the points that Graham made in his presentation and just talk about market conditions rather than get into anything too technical. But I am joined by my colleague Brian Purcell here, and if you do have any technical challenges for me, that's my man. So hopefully this will, and there might be a bit of sound in it.
We believe the future is ahead. So what will the fuel station of the future look like? We think it could be this. Charged by the sun, wind and the oceans, cars could empower people to store and then distribute renewable energy. So what can we do to really shift the balance from fossil fuels to renewables? Through our battery and intelligent drive technologies, we may have some answers. With Nissan's wireless charging and universal connectivity, our vehicles could autonomously charge themselves and then repark so another vehicle on the street could use the same bay, all while you sleep. And come the morning, your house and the grid could draw energy straight from your car, powering your home as you start the day. This is not just any street. This is a smart street. The cars, houses, roads and grid are all in sync, connected. Recycled leaf batteries can be turned into smart home storage so that no clean energy goes to waste. And it doesn't stop there. With zero emission technology, when you pull up at your workplace, you could drive straight into the office. An automated parking system would whisk your car away to be recharged, or the battery could even be used to power your office. The whole city could be connected. What if clean energy was so abundant that it became a free commodity to be shared amongst the city and its people? Our cities have the power to be transformed. Places once occupied by car parks and fuel stations could be replaced by green spaces, building a cleaner, kinder urban environment for our children and our children's children. At Nissan, we want to unlock the true potential hidden in our cities. And we believe that zero emission and piloted drive technologies could be the key. What if the fuel station of the future wasn't a fuel station at all? We believe the fuel station of the future is your home, your street, your city, your car.
So, a little bit of future gazing, but if I can get back to the present tense, help. Here we go. So I suppose that's a vision of where we could be going, and I'm definitely going to ask for assistance here now. Preston escaped furiously. So,
I think she brought it over here.
yeah. Yes, there we go. Thanks very much. So, just what I'm just going to cover today is, and I'll try and do it as briefly as possible, the context of EVs in Ireland. Ireland will be a world leader in the take-up of EVs. That's in the programme for government. I shall get this on slideshow. Sorry about that. So first one, yeah, bang, yeah. And in Ireland, what does a world leader mean? Well, about 5 or 6 years ago, it meant having 230,000 EVs on the road. Now, I'm afraid it means having 20,000 EVs on the road by 2020. And the reason for that is not because EVs are very nice, but it is key to meeting our climate change commitments, particularly those that we recently signed up to when we signed the Paris Accord, confirmed the Paris Accord, and our failure to meet those targets. And there was some pretty bad news yesterday about CO2 emissions and where we're going there, has the capacity to result in unquantifiable fines, really. But Joseph Curtin, an academic in UCC, has calculated that the exposure is between 3 and 6 billion. Other countries are making really significant progress. For instance, in Norway, there are 150,000 EVs on the road. So I suppose the question I'm asking is, what can Ireland do to catch up? I'm just going to skip that one. Yeah. So why electric vehicles? Well, Graham touched on many of the benefits there. Significantly less greenhouse gas emissions, and such emissions as they are not discharged into kind of dense urban areas, but they're discharged elsewhere. And also, again, something that Graham picked up on, it's a pathway to zero emissions. And by I suppose Tesla are kind of championing this position where you're looking at solar panels, a storage battery facility. Tesla call it a Powerwall, Nissan call it an X-storage unit, and the battery of the car all integrating, working as an integrated unit, powering the house using renewable sources. So you've got a very virtuous circle there. So and EVs are a clear pathway to that. The economic advantage, massive, 82% less running costs. A very interesting report that was got extensive press coverage in the UK at the weekend. A study by University of Leeds saying electric cars are cheaper to own and run. The 82% refers to running costs, but now actual owning costs are significantly lower as well. And I'll just touch on the recent benefits that Budget 2018 have given, which even improved that situation in Ireland again. Other benefits, health and safety, safe driving. Driving electric vehicles actually encourages safe driving habits, and reduced noise pollution, which would facilitate, for instance, nighttime deliveries, which will, I suppose, as that video clip kind of future gazed, can have great benefits for a city. So EV sales globally, what's happening? 2017 will be the first year that we've crossed the 1 million mark, 1.25 million. Next year, 2018, 2 million EVs are confidently forecast, and without a doubt the constraint is supply, it is not demand. So 2 million, that represents about 2.5, there's about 80 million or so cars sold globally. So 2 million, roughly 2.5. You're engineers, you'll do the maths better than me. But and so in cumulative terms, what are we talking about? 2018 with an extra 2 million will bring the kind of global fleet to about 5.2 million. And that's driven largely by the introduction, and again, Graham's chart demonstrated new models coming into the marketplace, encouraging adoption. So in 2017, well, the Tesla Model 3 was due to be released. That's the much vaunted kind of entry cost Tesla, with maybe a 35,000 ticket price, 200-mile range plus. It's been delayed. Where Tesla are challenged is getting into kind of mass production technology, isn't their bailiwick, so they've been making bespoke cars so far. So this is a challenge for Tesla. some people in the industry think it might be their fatal flaw to be able to become a mass producer, and you might see down the road Tesla merging with somebody who has that mass production technology. For Nissan, again, Graham pointed out, our 40 kilowatt car, it has kind of officially been launched. It will be in showrooms late January, early February. I can confirm that that bar you saw with the price will not be rising as dramatically at all, actually. Probably, we haven't got firm pricing yet, but it'll probably be about €1,000 only more than the current price is the indication we have. So the kind of efficiency will be significantly enhanced. There will be options to spend more money because that car will also include options around autonomous driving technologies, but that's an enhancement which would increase the price a bit. So what we're seeing is obviously the global fleet growing as a result of more and more choice for the consumer and better products. And I suppose that's what I'm saying. What's driving this growth? Well, regulatory pressures, and again, we've touched on them today, but what we're seeing is kind of the Paris Accord demanding a 40% reduction in CO2s by 2030. And again, unfortunately, yesterday we saw we're actually going the wrong direction in Ireland. So that's something we critically have to address, and it's more than just electric vehicles that are required to address that problem. In America, they've got kind of corporate average fuel emission standards, again, which drives automobile manufacturers to produce zero emissions so that they can kind of balance up the total emissions from their fleet. And again, what we're seeing is local diesel bans in cities right across Europe. And local diesel bans are kind of driving the consumer elsewhere and making the consumer question, if diesel is becoming kind of not a viable option, what will my diesel car be worth in 3 or 4 years' time? So that's driving consumer preference. In the UK now we're seeing a 30% decline in diesel. In Germany similar, and that's, you know, a function of Dieselgate. And it's really driving consumer petrol preference. Technological advances, and Graham really highlighted that very well in terms of demonstrating increased range and lower price. So that is obviously driving adoption, and again, greater consumer choice. So more and more manufacturers coming to the market, and really in the kind of Betamax versus VHS battle for technologies, you got to say that electric is the clear winner now. And why you'd say that is because all the manufacturers from their pronouncements have committed massive R&D. It's irreversible, the amount of R&D they've committed to electromobility, and they just can't shift. These are kind of 10-year R&D plans. In Nissan's case, Nissan has invested about 7 billion over the last 10 years in electromobility. So you just can't kind of swap horses that easily. And I think the argument is irrefutable now that the winning technology, as it were, will, in terms of the kind of passenger car, will be electric. So what is the official Irish position? The government sets a goal for Ireland to become leader in the take-up of electric vehicles. Programme for Government, Dennis Naughton kind of repeated that pretty recently, and a bit like a frictionless border, it has universal consensus down here. So Sinn Féin's position, Timmy Dooley, Fianna Fáil have a very progressive position, and the only person who might be kind of an outlier in all this is the great Danny Healy-Rae, who tells us that no one will buy electric cars when there's no facilities to plug them in, and they can only travel 100 kilometres at a time. So never a man to let the facts get in the way of an opinion. So Ireland's moving target. In 2010, the National Renewable Energy Action Plan set a target of 10% of the fleet, estimated to be about 230,000 for 2020. And what we've seen, unfortunately, is a kind of year on year, or every second year, kind of a decline in that target, to the point that the National Policy Framework for Alternative Fuels talked about 20,000 by 2020. And I suppose realistically, given where we are now, that is an appropriate ambition. It's disappointing that we didn't go hell for leather back in 2010, but we didn't. So the current strategy of getting 20,000 EVs on the road is still quite a significant challenge, as I'll demonstrate, but I think is achievable, and I think it's very important that we'll achieve it. That just represents 1% of the total fleet. So how are we doing locally? And again, Graham had this slide. I didn't include I've kind of restrained this to just EVs, as it were. So we're looking at around for 2017, and again, you picked up on used imports, because a lot of people don't pick up on used imports when they're tallying total EV sales. So kind of 1,200 roughly this year, which isn't a bad number relative to, you hear some rather ill-informed journalists talking about, you know, the non-EV adoption. 1,200 isn't a bad number, but we clearly have set ourselves significantly higher targets. This is the way we think it'll go. I think indigenously, that kind of 700 new will grow to about 1,500, will definitely double. And again, I think the only constraint here is supply. It's not demand. I know that from talking to, say, my colleagues in Hyundai who have the Ioniq, from Renault who have Zoe, and for ourselves, we have to battle now to get supply from our manufacturer. So I think the big constraint on the growth of electric vehicles in Ireland over the next few years is supply. And that again is probably not a bad thing when I come back to and talk about the charging infrastructure. But we believe that by 2020, on our current trajectory, we're probably going to be about 5,000. I've just hold steady used imports as a projection. It's crystal ball gazing. It's a function of Brexit and 1,000 other things. So we just don't know that number. So that would take us on that trajectory to about 14,000, substantially less than the 20,000 we're targeting. But I think there's ways that we can address that. That would represent 0.6 of the fleet, which obviously is a little bit short. Now I know you're engineers and not accountants, but help is at hand, and one of those big helps has been the very, very generous provisions that came across in budget 2018. I'm not going to walk you through those numbers, but essentially, accelerated capital allowances, particularly for a sole trader, confer massive benefits, probably a saving of almost 11,000 euros if you're a purchaser of a kind of a Nissan Leaf at a ticket price of around 25, 26,000. If you work for a company and you get a company car, there is zero benefit in kind. I mean, this is a massive saving. It's a huge incentive that came in the last budget. So zero benefit in kind for a car, the equivalent of a Nissan, so that might be a Golf or a Ford Focus or something like that. The normal circumstances, you will be paying tax of 360 a month if you got that as a company car as by way of benefit in kind. Zero if you have an EV. So that's a huge, those are two huge savings, and I think that they will certainly, they're very progressive policies, and I have no doubt that they'll drive the adoption of EVs for those lucky enough to be able to get one. So how do we rate as a world leader? Well, Norway is the world leader. It's the gold standard. Similar demographics, 5.2 million population. Probably Ireland has a better climate for EV adoption, and the same cars are available in both countries. Similar supports, but actually Ireland now has better financial supports, and both governments are committed to be EV world leaders. However, 150,000 to 3,200. So Norway are now 47 times better than us. So we really have to kind of address that. As I say, I think the government has come to the table in terms of the financial incentives that came about at the last budget. And so then we ask ourselves, why the difference? Well, in Norway, EV driving is encouraged and rewarded. And in Ireland, not so much. And why is that? And I suppose if we just look at the kind of soft benefits, in Norway, free parking, free tolls, access to bus lanes, and a great charging network. We don't have those qualities in Ireland, and I'm afraid because of the evolution, we started out with a pretty adequate charging network, but the current condition of our charging network leaves a little bit to be desired. We have not reinvested in our charging network and there are issues going on as to the ownership and the management of that network, and it really is making the experience of owning and driving an EV in Ireland at the moment rather difficult, and that is something that urgently needs to be addressed. There is no doubt that infrastructure and charging infrastructure reinforces and supports and drives the adoption of electromobility. Once people see charging points, it gives them the confidence. They may never actually need to use that charging point, but the confidence and the reassurance that it's there drives electromobility. That's a proven fact. They've proven it in Norway, they've proven it in California, and they're proving it elsewhere. So Norway, we have this lovely image of, there's a Nissan Leaf whooshing down a bus lane. That is not going to happen in Ireland. I've spoken to plenty of people in positions of authority, Dublin City Council. There is no way their precious bus lanes are going to be invaded by electric vehicles as far as they're concerned, regardless of the positive benefit that might have for the city. You have fantastic charging networks, as I say, and access only for electric vehicles to those charging points. This, sadly, is the position in Ireland. Cars getting clamped while they're charging, or big gas guzzling cars actually occupying the spaces in front of charging points, and they can do that quite legally. I mean, it's absolutely ridiculous. So we have a charging infrastructure that we can't even access. Significant investment made in that over the years, and you have images like that. So I suppose I asked the question, why are we failing? That's why we're failing at the moment. The reality is local authorities have the biggest influence on our driving habits, and there is, with a few honourable exceptions, on the transport side of the local authorities, not that great a buy-in. What we're seeing in other parts of local authorities is a great commitment to electromobility and to lowering CO2 emissions. But on those who have responsibility for the transport within the city, we just get pushback and pushback. National government policy has which has stated that Ireland is to be a world leader, it has failed to influence local authority action in many cases. So local authorities don't really have skin in the game, and there's no downside to the local authority for non-performance. It's the national government that'll have to pick up these fines, not the local authorities. So I think something needs to be addressed there. Hence we have images like that. So what does failure mean for Ireland? Well, as we heard yesterday, our CO2 emissions will continue to rise. That's also to do with the surge of diesel engines that we're importing, which is a separate issue. But I mean, how are we going to drive our CO2 emissions down when we're taking in about 80,000 cars that really wouldn't be allowed into any other country? The health of our citizens has been compromised. We'll fail to meet our emissions, and huge fines, as I mentioned earlier. And unless we address some of the issues, we may not hit 10,000 units. So we need a rational outcome to the CRU review of the management of our charging infrastructure. And that outcome has to be consistent with government policy, and it's got to be designed to encourage EV adoption. And hopefully that outcome will be a well-maintained, accessible infrastructure with a kind of a sensible tariff structure. I think a tariff structure is essential, but it's got to be essential. It's got to be a kind of a sensible one. Is 20,000 achievable? I think it is, and I think these are the things. Some of these have been done, some have not been done. So I did this for a few months ago. BIK relief, we have it. So I think that's going to be a key driver in terms of driving forward. Taxis, we're seeing now that there's going to be policies regarding a taxi scrappage scheme. I think that's really progressive and an excellent policy. To go with that, we have to have the charging infrastructure. You can't ask a guy to drive a taxi and not be able to fuel his car. So, it's no good having them available for half the day. Public purchase, and we're already seeing again some Dublin City Council being quite progressive in this regard, and other councils and public authorities. But after the Paris Accord, a lot of nations signed up to a commitment that kind of public authorities, 20% of their fleet, of all future fleet purchases would be zero emission. I think that's something that we should sign up to here. I know there is quite a progressive attitude amongst many councils and many public authorities in this regard. It's great to see. I hope it continues. The charging network I've referred to, the soft benefits I think would be huge. parking or tolls. It's a reinforcer. The cost to the exchequer is modest in respect of that. Certainly even the cost to the city is very modest, and I think that is a very positive signal. Whether we get bus lanes, it's aspirational, but the resistance is huge. And fine local authorities, I think local authorities have a huge responsibility with regard to electromobility adoption. They have a huge part to play, so they should play some of the cost if they're not at least introducing progressive policies. So develop, maintain and promote a suitable national charging infrastructure and get local authorities to buy into it. If we do that, I think we can get to the 20,000 target. So that's my tuppence worth. So thank you very much indeed.
Thanks, guys. That was really fascinating, really interesting, and well thought out presentations. So thank you for that, and again, thanks for keeping to time as well. So we'll have a bit of Q&A, guys. Now it's 9:30. If you've parked your car outside, it's free up until 10 o'clock. So we might try and leave until around 10 to 10, 5 to 10. I might just kick off. I'll give the guys a microphone to share, but I might just kick off. Can I ask what has been the experience that you've found of EV drivers in Ireland? I don't know, is it too early at this stage to run the numbers on? Are there people kind of repeat purchasing electric vehicles at this stage and coming back, or what's the general consensus? And maybe between the three of you, if you have any feedback.
Well, our experience in Nissan is the kind of satisfaction index is 93% now. That is off the chart relative to pretty much any other vehicle. So our greatest advocates are EV drivers. Their satisfaction with the car, I mean, they're passionate about it. So we have that very positive experience, and as I say, they're advocates. The negative, I'm afraid, is the point I raised there about access to the charging infrastructure. If we can address that, we have a happy customer, and you know, as I say, we do. So the experience is superb. It's fantastic.
Yeah. We did some surveys of consumers and drivers as well, and we found the number one reason that people buy EVs is because of the fuel cost saving. So, you know, it's not so much the environmental benefits and things like that, it's really they save a lot. So we did a kind of a rough survey on the mileage, and we found that the average mileage it's not untypical to find them driving 25,000 kilometers a year. The average mileage is about 16,000 kilometers, so they're clearly getting their value out of their investment. We also asked them how can we go and promote them and increase the uptake. And about a third said more incentives, a third said infrastructure, and a third said more awareness campaigns. So getting people in driving EVs and things like that.
Any questions from the audience?
Sorry, Raoul MP, Sustaneo. James, very interested to hear that the problem is more supply than demand. The demand's there. Some questions that often come up, and I'd like to, as we got the experts in the room, if you could maybe answer what is the real answer to this. Is there a problem with the supply of lithium and rare earth magnets? And also there's a guy, David Connolly, I think he's in the Irish Wind Energy Agency now. He was talking about e-roads as a way to get to 100% renewable transport, where e-roads could power heavier trucks as well as the smaller cars, and it might also allow us to have vehicles that maybe have half the battery mass in our cars, maybe making them a little bit more cheaper too. So I was wondering if you could comment on those two aspects. Lithium, rare earth magnets, and then possibility of e-roads.
I'm going to flick that over to Brian.
Sorry about that.
Okay, so quite a good question. The relation to supply and demand that we're speaking about is not really about the supply of lithium. What we're talking about here is the massive uptake by other European countries in EVs in general, but particularly in the new 40 kilowatt hour car that we have. The lithium contracts, I'll call it, that are out there at the moment with other countries will probably be enough to supply the ramp up in production that's required. But as James pointed out, with Norway being 47 times more advanced, we'll call it, than Ireland, the mass of production will head towards Norway, Germany, UK markets, rather than just into Ireland. On a general basis, I would say that the development of batteries will probably move away from being just confined to lithium, and we'll see other battery chemicals and other battery formats coming out. And the other piece I would add is that in a lot of the presentations there was reference to huge battery capacities. And the fact of the matter is that we're talking about C-segment family cars and we're talking about a Leaf. Now, when you get into sort of 80, 90, 100 kilowatt hour battery capacities, you're talking about cars that have, yes, they've got a longer range, but you're also talking very much about performance cars. And I think this is something that's misunderstood in the market, and there should become a sensible average size of battery which should share out the available lithium into reasonably sized battery packs and reasonably sized expectations on what journeys an EV can do. Statistics show us that for Ireland that 80% of all journeys are less than 80k a day, and sticking with those 80% figures, your car is basically static and idle for about 82% of the time. So during all that time, it's neither consuming power nor is it providing power anywhere. And this is where, as a number of the presentations pointed out, that the power to discharge your battery as well as the requirement to charge your battery are going to bring, some new advances in combining transport into buildings and into sustainability generally.
Thanks, Brian. Just to follow up on your question there, there's only about 1% of it is lithium. There's a small amount of lithium in it. It is one of these, like on the International Energy Agency, we deal with the US and the other countries, and we've talked about these journalistic questions that come in and maybe produce fact sheets. So the US Department of Energy looked at the lithium supplies. There's tons of it about. It's the production rate of the lithium has to rise. So I think last year was the first year that the lithium for electric vehicles exceeded the amount of lithium used in any other battery application for mobile phones or whatever. So that's going to rise. But they are starting to invest in the refineries now to make the lithium. The other one, neodymium, is a rare earth element. It comes from China, produces most of it. And I think the European approach is to recycle, pull these expensive things out of electric motors and use them. They're used in wind farms as well. So the idea is to recycle those things. But as you saw, Tesla were using an alternative anyway. They weren't using rare earth magnets. They have an AC induction motor, so it's a squirrel cage rotor. So it's usually thing. So there's ways around it as well. E-roads, I have one bee in my bonnet about E-roads. If these are things that are going to deflect, well, they're taking energy from something. It must be like, walking through sand, there must be kind of a sogginess to the road. So energy's been taken from something. It must be the car. So the kinetic energy of the car has been taken and converted. So you might have to push up the power of the car, if that's how it works, through deflection. Anyway.
Yeah, question for James and or Graham. So the sick and tired about hearing how great Norway is at everything from education to health. Don't think they're as good as us at soccer, I'm not sure. But if you woke up in the morning, what would the one kind of piece of subsidy or maybe policy you put in place to increase the use of electric cars? What's the one single item you might put in the agenda?
We granted one thing tomorrow?
Yeah, if you're Minister for Energy in the morning, what's the one thing?
Access to bus lanes. Absolute game changer. But I think the subsidies we got in budget 2018 are significantly generous, or very generous, and have the capacity to drive things forward, particularly while businesses look at their fleets, and there's a double win through the accelerated capital allowance and through the benefit in kind. Businesses can be quite creative around exploiting both of those tax advantages. So it really takes the cost of an electric vehicle. There was a myth for a while that electric vehicles were expensive. Well, some of them are very expensive, but some regular cars are very expensive as well. The entry price of a Nissan Leaf, as Graham pointed out there, was around 22,000. It'll probably go to about 25,000 now. And that's the equivalent car.
Why do you think, James, bus lanes are so sacrosanct in Dublin compared to Oslo?
Very good point. I think you need to talk to Dublin Transport Authority, and who are very pro public transport, which is laudable and in agreement. But there is some idea that there's 3,200 electric vehicles in Ireland. Of those, there's probably 1,500 max in Dublin. Of those, there's probably 200 on the road at any one time, if we use Brian's maths. How could it clog up bus lanes? No, it's ridiculous. What you should do is allow them into bus lanes until you have a critical mass, say until you hit the 20,000, then stop it. If it's becoming a problem, if it's slowing up bus lanes, just say, job done, move out.
Thanks. Graham, have you any comments on that?
On incentives or
One single.
I'm not sure there's one single thing. Our incentives are not bad in terms of the capital purchase of the vehicles, I think maybe the awareness stuff, getting people into electric cars and get that wow factor, that they really perform very well, and getting the public interested and excited about them, will help as well. But definitely infrastructure, more generous. I think we have to be generous, especially with fast charging infrastructure. You shouldn't have to arrive and there's one fast charger at a petrol station and it's blocked by somebody else, in the early days at least. Maybe when there's hundreds of cars passing through, then you have to put up with it on occasions. But I think we should go for that if we can.
Hi, Senator McGrath. I've recently retired from ESB from working with the European Commission and on electric vehicles and working with Euroelectric. Maybe just a couple of comments about what things that I was very heavily involved with the Irish government in lobbying. We thought for that BIK. In fact, we thought we had it last year. If it wasn't for the problems with the new government, I think we would have had the BIK last year. But it was they decided to postpone it a year. So thankfully it came in this year. In relation, I would have lobbied a lot, and I'm very familiar with the situation in Norway, about the bus lanes too. I understand, and I think it would be a very useful thing. However, I think it's always important, if you're lobbying for something, to understand why the other people have a different view. And everywhere around the world, people who are supporting alternative technologies support the idea of doing as much as possible. But bus lanes always is the one, access to bus lanes is one that everywhere causes friction between people who support in the main public transport, who think the answer is more public transport, and people who, so there's the added complication in Dublin, just to make sure that you're aware of it, that where it is the difference between Dublin, and I'm speaking in favour of bus lanes myself, but just to understand it. The people in Dublin City Council have a huge concern because the numbers of taxis that have access to bus lanes in Dublin far exceeds the number of taxis that would have access to bus lanes in places like Oslo. So there is that difference to bear in mind. And maybe just to answer the question that you posed to James, what is the one thing, in my opinion, and I've been very involved in America with the situation. If you look at, and I won't go into the details, if you look at the difference between Colorado and California and places like that, and if you look at the key thing that I would ask, and I have blue in the face over the years asking the Irish government for, yes, we want a whole lot of incentives, but that's not the key thing we need, is coordination, is pulling it together so that you don't have this thing, that you have Dublin City Council telling EV drivers, ESB put charge points without consulting with us, and that's why we won't allow free parking. When actually what they mean, if you point to it, it's a bit like a lot of this Brexit stuff and the politicians. The people who say that in Dublin City, that they weren't consulted, I mean, they personally weren't consulted. Dublin City Council were fully consulted. The planning people, different people, were always consulted on the location of charge points. But the people in charge of parking weren't consulted. So they object. You have one council, you have O'Leary Rathdown, who's very supportive. But you go across the, you can get free parking in O'Leary Rathdown, but not in Dublin. You find different people in different government departments very supportive, but you'll find there'll be objections from other government departments. There isn't coordination of the thing. Very enthusiastic people in some departments, but not all pulled together, and that is the main reason that Ireland has failed. It's a lack of proper coordination.
I have a question for Graham and for the two people from Nissan. First of all, I completely accept the logic of the efficiency of electric vehicles, but it seems as if the preponderance of cars being sold will be internal combustion engines, as we're being disturbed listening at the moment. I would like to get an insight into, in a couple of years' time, what choices are people making about the cars they're buying? They're obviously still going to be predominantly buying internal combustion engine vehicles, but is there a move towards hybrids, or what are we going to actually see as we transition towards a much higher percentage of electric vehicles?
We did some surveys, and we found that it was a general public survey. We found that 70% of them said that they would consider an electric vehicle at some point. But you're right, like the consumer is already picking up on these signals that diesel is bad, and we've seen change in the buying this year. So we've seen the sales of diesel start to drop, but the sales of hybrids, like the Prius, start to rise. So what we would see happening is the pattern is that they take an interest in a plug-in hybrid vehicle, and as you've seen there from looking at the components, it'll eventually be a no-brainer that carrying a lump of metal around to produce backup power for your electric drive doesn't make any economic sense at some point. So we see the PHEV as a stepping stone for people that are worried about infrastructure until the range of the cars is there, and then we see a transition to vehicles. That's the way I would see it. But I definitely think it's important to make your statement so the consumer knows well in advance. So make your 2030 commitment to have zero emission vehicles, and that creates this huge psychological bearing on the consumer's choice.
Sure. I can give you a figure. It's pretty much hot off the press. If we look at look at the different powertrains, petrol, diesel, hybrid, EV. So Nissan, and we're kind of mid-market, classic sample of probably with a slight legacy towards petrol anyway. But if we take Qashqai, which will be our largest selling car, which was second highest selling car in the country, in 2016 the mix was 80% diesel, 20% petrol. 2017, 70% diesel, 30% petrol. We're looking at pre-sales that are about 52% petrol, 48% diesel. I know the Peugeot 3008, 2017, their mix is 75% diesel, 25% petrol. That's in their pre-sales, that has flipped.
And are the petrols hybrids or are they?
No, Toyota's sales 2 years ago, 4% of their sales were hybrids. 30% of their sales in 2017 are hybrids. And I suspect that you'll see a bigger number there. So it's quite interesting if you look at how motor companies are developing. What you're seeing is a reduced number of models, but they'll be developing more powertrain options within those models. So you'll see diesel, petrol, hybrid, mild hybrid, electric. And they're the choices the consumer will be having in years to come. It'll be different powertrains. So there's very interesting things kind of emerging around these. Like Nissan produced a car in we have the Nissan Note, which is kind of a small car. Japan, they produced the E-Note. And the E-Note is what they call a mild hybrid. It uses kind of electric technology. It leverages that electric technology on a petrol engine. And it became the highest selling car in Japan in the first half of 2017, outselling the Prius, and they had no expectation that it would achieve this level of sales. So what you're seeing is kind of powertrain options emerging. That'll be very interesting, but all driving down emissions levels, so it's a very positive thing. So it's an evolving, there's no quick answer to your question, but it is a very interesting feature in the industry.
I'm aware of the parking outside, so
yeah.
Thank you.
Yeah. Okay, guys, just before I wrap up, I might ask Professor Owen Lewis from the Energy Institute just to give us a final thoughts.
Thanks very much indeed. I think we're indebted to the three speakers, Chairman, who's given us very valuable insights into an area which is clearly a very exciting area. The pace of change, not just in relation to electric vehicles, but the scale of and pace of change is very exciting. And we've also got glimpses of very different futures, which are perhaps coming closer or maybe coming to us more faster than we anticipate. Because when we're talking about cleaner cities, cleaner transport, in reaction to the huge problems of health and comfort in our cities now, envisaging clean vehicles with zero emissions mean our streets start to change. The quality there, which means our buildings change because we no longer need to seal out the dirty urban environment. The changes in terms of the grid and so on, and building storage into a largely intermittent electricity generation system, also very exciting. But I suspect Senan McGrath put his finger on the biggest challenge. We're not great at joined up thinking in this country, evidently. No one has referred to the Department of Transport, which might have some relevance to this topic, and the regulator needs to understand what the kind of changes that are occurring. So they seem to me to be very particular challenges. But our thanks and to the three speakers. Thank you very much.
So thank you, Professor Lewis there, from wrapping up. Just from my own perspective, again, thank Graham, James and Joe for fantastic presentations. Really, we always try and struggle to get the mix of future gazing, but also we're Engineers Ireland. We like to have a bit of engineering around discussions as well, and I think the three guys really addressed that. Finally, one quick plug. We the Energy Environment Division have Professor Barry McMullen speaking tonight at 6:30 here, and be webcast as well, and we'll be speaking about negative emission technologies in Ireland and the potential moving forward. Again, finally, I'd like to thank the three guys for presenting, the Energy Institute for co-hosting the event today, and Billy Condon, from our own Energy Environment Division for doing all the heavy lifting for today. So, ladies and gentlemen, we can just wrap up thanking the guys again, and wish you a good day. Thank you.